Hi, I'm Chelsea Tryon, and
I'm Lauren Oliver.
I'm Jose Ramirez. I'm Sailor Rowan. So our problem is basically in today's building sector, buildings consume about 40% of our energy, total energy production. So being that that is the case, we decided to actually work on a building that produces all of its own energy and then some. So that's what we consider a net positive energy building. So what we set out to cover is to be fully sustainable, as in cover economic, environmental, and social goals throughout the project. So, next slide. So we'll start off with the Living Building Challenge, which sets the specifications for net zero energy certification. And so Chelsea will go over the requirements and performance areas for that. And then we'll go into sustainable technologies of how we actually accomplish that and the design requirements that helped along the way. And so with the sustainable technologies, that is geothermal, specific ICF insulation, lighting, and our solar panels which produce the energy, and then passive design and biophilic design. So I'll hand it on to Chelsea.
okay, so the Living Building Challenge, you can access it online to see all the requirements if you want more information on it, but it touches, for it you need to develop a certificate program, which is what I was just telling you, you can access the requirements online. Advocacy tools and philosophy, those are like the main 3 points that they focus on. To break it down more, the 7 performance areas that we have to focus on is basically everything in our building. So not just energy. So first with the beauty of the building, we have pictures of this later on in the slides to show you as well. For beauty, we have like plants inside for interior design of the building, which also affects health in the building. It's a lot easier to breathe. For lighting in the building, that also affects our health because we're using the natural lighting from outside instead of like these intensity lights that cause people to get headaches throughout the day. Another thing is regarding like society and equity, we plan on offering free tours of our building. Our building's going to be located in the empty lot next to the view, right on Apache. It's going to be a single-story building, and it's going to be bike accessible as well. We're going to try to promote bike riding through there. It's a single-story building, and that is specific for a reason because one of the qualifications is that you do not impose on another building nearby of achieving net zero energy. And if we made it super high, we would cause shading, and they wouldn't be able to use solar panels. So it's a single-story building for that reason. Another thing is our office furniture inside will be made of recycled and repurposed materials. We also have pictures of those. We have a metering system similar to campus metabolism that we're going to implement, and this is very, very important because we have to provide a year's worth of our results to the Living Building Challenge for us to become certified. We would meet LEED certification, but it's not really in our funds to try to become LEED certified right away, so we plan on doing that later on with this building. Yeah, so this is just another explanation of it. Certification verifies the building is truly operating as claimed, harnessing energy from the sun, wind, and earth to exceed net annual demand. It's the one thing to say that the building is zero energy. It's another thing to prove it. So that's just pretty much the goal there. I'll go into the technologies with Lauren.
So the sustainable technologies, energy generation, most of the energy is going to be provided by solar panels. We're going to have 292 solar panels on the roof. They, instead of pivoting this direction, they pivot this direction. And each panel measures a little over 4 feet by 2 feet, almost 3 feet. And we're going to be using the Sanyo solar panels, and they provide 200 watts per panel, and this comes out to 99,280 kilowatt hours per year. For the lighting, because that takes up most of the energy in a industrial building, we actually decided to use natural lighting, and the way we're going to do this is through a Swedish company called Perrins, and it's solar fiber optic lighting. The receivers, which are right here, they are 110 centimeters by 45 centimeters, and the light capacity is equivalent to 14 units of 40-watt bulbs. These can theoretically pivot 360 degrees, and you can mount them on the side of the wall, the side of the building, or on the top of the building, basically wherever you need them. And then the fiber optic cable flows throughout the entire building, and they come in 5 meters, 10 meters, and 15 meters, and 20 meters. So depending on where we position them on the building, we'll use 5 meters to 20 meters for each one. And each receiver, they give out power to 3 luminaires, which is not these, but it would be similar to these. I have them on the next slide here. You've got the larger ones right here. We can have up to 3 of these, and that's actually the ones we would use. But you also have the option to use the smaller ones here, and there's also spotlights too. This building here shows you on a multi-level. Obviously, that's not our building, but what it could do. And you have a receiver on the ceiling or on the walls here, and then it transfers through here, and then it provides light here.
Now, how are we going to keep the building cool? Our main portion of the insulation, we're looking at ICFs, insulated concrete forms. Basically, what it consists of is a styrofoam that's placed in between. So when they're building it, there's actual blocks of styrofoam. As they're building it, it goes up a level, but in between, they have a cavity which they fill with concrete. With this wall, they're actually saying that their R value are 35 plus, depending on the area you're at. So if you think about creating R value or insulation, an R value of 35 is huge. In their statements and studies, they've shown to actually reduce cooling costs by 55%. The major benefits of these ICFs is the quality. The material that is used is highly durable and strong, and it's easy to access. It's sustainable in the sense that they use a lot of recycled material, and going forth, the rest of the material is actually 100% recyclable. The strength and safety, their walls are actually rated to receive winds up to 200 miles per hour. Comfort, they reduce noise, they reduce moisture, which will also go into impact, and also eliminates convection. So how are we going to cool this area? We're going to use geothermal heating and cooling for our area. Basically, geo-exchange units or ground source pumps, as you like to count them, instead of geothermal. Installed, we're drilling holes roughly around our area. They're supposed to be about 400 feet deep, about 10 feet in length, and distance in between each loop. And for our unit, we're actually looking, since we got such great insulation, we were able to reduce the actual tonnage needed for our building. So we will be installing a closed loop system that provides enough cooling for our area. Actually, we won't even need the total amount. Another study that showed that in Phoenix, since it's so dry, we get a reduced efficiency from geothermal. So an easy alternative that they found was this evaporated fluid cooler, which actually ties into the refrigerant loop that evaporates water through it, where it actually increases or returns the efficiency to geothermal heat pumps here in the valley. With the system tied in together, as you can see, here's the cooling tower that's tied into to the ground source. With this system together, we get Sears and ER ratings of 35 to 30 per the units.
So onto the passive design features. Basically for this, we wanted to eliminate as much heating and cooling from the geothermal unit as possible. So what that includes is day lighting, so that we don't have to use as much of the plan's lighting, or during the nighttime. We can actually buy back energy from the utility company that we sold them for a higher price during the day. So we're actually making a bit of a profit off of that. So we have solar shades that actually help with the passive design. So during the winter, you do get full access from the sun into the building, as you can see down here. And during straight winter, these kind of go in deeper. And during the summer, obviously, it's covered in shade. So what we also included was a reflective mirror that goes just along here. So what that does is it reflects the sun's light, but not so much as the heat actually farther back into the building. So it comes up around here, and but it doesn't hit direct surfaces that people interact with. So that's a key way to keep heat from staying in those materials. And but it does reflect off of the walls and ceiling. So besides that, we have double pane windows, which do allow a certain amount of heat in the winter time to come into the building, but also, as I said, during the summer, it's the reverse. So with natural ventilation, we didn't have to use like any large fans or HVAC units to move the air in the building. So how that works is on the ground floor, or on the ground, basically we have vents that are filtering the geothermal cooling air in, and it's pressurized, so it's actually denser than the air that's inside the building. And so it comes in and forces the warmer air from the computers and that interact with our body heat, forces that air up towards the ceiling. And along here, there's a window that stretches along three sides of the buildings that does open up to the exterior, and with a little black strip above it that gets hot, obviously, when the sun hits it. It heats up that air and creates a circuit of air from the geothermal unit out to exit through these windows. And so that also ties in the pressurized cooling effect. So the biophilic interior spaces. So biophilia is describes the instinctive bond between humans and other living beings. So this is what we wanted to tie into the beauty part of the Living Building Challenge. So indoor plant benefits. There's been a number of studies. I'll cite one, Dr. Robert Ulrich from Texas A&M. And these studies go into the psychological effects of plants on humans and the benefits that we get from them. And so what they have shown are we get productivity benefits, health benefits, and obviously visual connections to nature, which in a lot of today's workplaces with how the cubicle has evolved, has not really been for the benefit of the worker. So these units do provide air purifying characteristics, as well as the structure is a hydroponic system that uses the gray water from like the sinks. And these partitions reduce noise and visual pollution, and the hydroponics make caretaking of the plants easy and practical. And just overall, they create a tranquil and alive environment in the interior space for the workers. So, in our conclusion, we hit all of our project targets, which were mainly so to cite the three, we have the economic, the environmental, and the social goals that we wanted to access or to hit from sustainability. And so in the economic sector, we got profit from the utilities because we're selling energy from the solar panels to them during the day at a higher price than what we would be paying at nighttime for any lights that we may need to use. And so we're making a profit off of that. And then with the environmental, there's zero carbon emissions in the energy consumption.